All right, you guys. So now a more challenging problem. When we first, now that we've introduced ourselves to the inverse trig function, we know it's going to return a value for us, and so it kind of made it easier for us just to find the button to get used to it. But there's a more deeper thing to this because we know an equation like this, sine of theta equals 2/3, right? We have to consider eventually all the angle values within the first full rotation, not just one. And so when we think about this, right, when is sine positive? Well, because r is always positive, right, this is going to be positive when y is. So that happens in quad 1, and that happens in quad 2. So when I invoke my inverse sine function like I'm going to do in a moment, right, so there's what I'm going to be putting in my calculator, and what I'm going to get, right, is I will get an angle value, right? So let me put this a little more in the light. So we've got the inverse sine of 2 divided by 3, right? And that's going to give us a value of 41. Let's just call that, let's go 2 decimals here for the sake of argument. So 41.81. So this gives us an angle value of 41.81 degrees. Now that gave us the quad 1 answer, which we were expecting, right? So that's that. But what about the quad 2 one that we were expecting? How do I find that? And what we're going to do is fall back on our reference angle. So let me draw a bigger picture here. So we now know that in quad 1, right, if I have an angle of 41.81 degrees, that has the right y and r. In this case, it's basically 2 and 3, right? That combination, right, goes along with the angle of 41.81 degrees. Well, in quad 2, we now know that the reference angle over here of 41.8 degrees also has the ratio 2 and 3 for y and r respectively. So what we're really looking for then in quad 2 is this, sorry about that, we're talking about this angle right here that I have in red. So how do I find that angle that will also make the sine equal to 2/3? Well, again, with that reference angle we have here, that theta I'm looking for is basically 180 minus 48.1. So let me go ahead and use my calculator here. So 180 minus 41.81 gives us 138.19. So the other angle is 138 and 19 degrees. So there's the two values. That's the quad 2 value that also makes sine equal to 2/3. Again, very easy to check. Before I do anything though, make sure we did round off here. So I'm not going to get something perfect. So the ratio we're looking at is 0.666666 on for forever. So if I take the sine of 138.19, right, that should be really close to 2/3, or 0.666666 on forever. Press enter, and lo and behold, right, we have it. We're almost 1, 2, 3, 4, 5 digits. And again, we're off these digits because of the round off error that we made early in the game, and we compounded it later. So we want more accuracy. Don't round off to 2, maybe do 3 or 4, or keep it as accurate as you can. But that is the full picture. So we're expecting 2 answers. The technology gives me 1, and then my knowledge of reference angles and where I'm positive, so previous knowledge, previous trig knowledge, helps us find the others. All right, so let me do one more, and then I think I'll have to cut to another video because I don't want these to go too long. So what about the cosine of -1/4? Well, again, this is going to occur, right? We know that r is always positive, so when's cosine negative? Well, when x is negative. Where does that happen? Well, that happens in quad 2, and it happens in quad 3. So I'm expecting 2 answers. So we're hoping that the technology gives us 1, right? That's what we're counting on. So there's what I'm entering on my calculator. I'll go to my calculator, type in the inverse cosine of -1 divided by 4, right? Press enter, and lo and behold, what I get, how about we call that 104.48. So we get that theta is about 104.48 degrees. So which one is that? That's our quad 2 angle. So we're guaranteed to find that one. So far so good. But what about the quad 3 angle? Well, again, right, if we come over to our picture, here's what we have for this picture, right? So what we have is we know, right, that we're going to be rotating, let me put it in red, 104.48 degrees, right? And that's going to create this situation. The situation we have is x is -1 and r is 4, right? And then there's some little reference angle sitting right there. But we also know in quad 3, right, that also has pretty much the same ratio where x is -1 and r is equal to 4, and that reference angle is basically going to be the same. So in order to find this other angle, let me go ahead and put this also in red, to find that angle right there, right, we basically need to find the reference angle. And then once I find that reference angle, I can go 180 plus that reference angle and find the other one. So let's find the reference angle first. So for my picture, this is 180 minus 104.48. So my reference angle, let me come over to the calculator, is 180 minus 104.48, giving us 75.52. Okay, so the reference angle is 75.52, and it's the same reference angle down there because it's the same triangle situation. So what's the angle that I have? Well, the angle we're looking for here, my theta, would be a 180-degree rotation plus what we just found is the reference angle. Right, and then putting that together, right, I'll just add 180 to my answer, and it looks like our other theta, again, you notice that it does in fact fall in quad 3. There's our quad 3 answer, right? So the quad 2 answer was given by the technology, 104.48. I used my knowledge of positivity, or in this case negative, where am I negative, and reference angles to help me find the other one. And again, easy to check, right? If we find, again, the ratio is -1/4, so that's what, -0.25. So if I find the cosine of 255.52, right, again, this will be an estimate because of my rounding earlier, but when I click it, right, there we go, we're at -0.25, a couple of zeros. So it's off a little bit because we rounded off the answer there. So we want more accuracy, don't round off so much. And of course the cosine of 104.48 is also going to give us the same thing, same ratio, all right, because it has the same reference angle, has the same corresponding right triangle. So there's how we're going to use technology combined with previous trig knowledge to help us find all the angle solutions within the first rotation. The next one has another challenge that'll pop up, so I want to cut away to a new video where we can capture that crazy nuance in the next one. So see you guys in one more video.